All right, so for today, we're going to go ahead and cover angles. So an angle is a figure made up of rays or sides. Okay, it has a common endpoint called the vertex of an angle. So here's an example. If you notice, we have two rays. You have ray yx and ray yz, and together they make up angle here. Now the vertex is y, so we could call this angle y, or by the number that they have in here, that's also considered angle 2. So it says here there are 4 ways to name this angle. And go ahead and ignore this. I think that's a typo. It should have little symbols here. I think I had trouble transferring it onto the notes page, that it switched the little symbols. But anyways, here it says you can call this angle y by using the vertex. Okay, so our vertex is y, so you can call it angle y. You can also, by the number, angle 2. I think those are the 2 easiest ways. And then the next way is by using 3 letters. Now, when you do use 3 letters, you do need to be very careful. You can start off with x, y, z. You go from x to y to z. So that tells you that we're talking about angle y here. Or you can go in the opposite direction. Z, y, x would mean the exact same thing, as long as a y or your vertex is in the middle. Okay, so just be careful with that. So here we're going to go ahead and identify the vertex. So if we look here, the vertex is Q. Now we're going to put here point Q. It's our vertex. They want us to identify the side. So we have 2 rays. Our first ray goes from Q to R. We're going to put QR with a little arrow on top to show that it's a ray. And the other ray is QP. Q to P. Okay. And then it says give the 4 angle names. So I'm going to start off with the easy ones. The easy ones are angle Q, okay, with the vertex. The next one is by using the number. So our number that's in that little angle, sorry, my pen turned off. Angle Q, angle 1 would be the next name. And then now we're going to label it using 3 letters. So remember, we need to go in that order. P, Q, then to R. So P, Q, then R. Or we go in the opposite direction. We go from R to Q to P. So I'll go RQP. Remember, the important part is that Q is right in the center. Okay. All right, the next one. So we'll practice this again. Name the vertex. So our vertex is point J. Okay, it says identify the sides. So the sides are made up with rays JH and ray JK. And it says give the 4 angle names. So the first one would be angle J, just using the vertex. Using the number would be angle 5, and then we're going to use the 3 letters. So we go from H to J to K, making sure that the vertex is in the middle. So H, J, K. Or we can go in the other direction, starting with K to J to H. Okay, so the next section says name 3 different angles. So there are 3 different angles. Okay, the first one would be from A to B to D. Okay, so angle A, B, D. Or you can go in the opposite direction where you said D, B, A. Okay, that would be talking about that section right there. The next section would be D, B, C. So it would be talking about this part right here, that angle. So angle D, B, C. Or it's also known as C, B, D. And then the third angle is a whole thing from A to B to C. Okay, so that's why you need 3 letters sometimes. Angle A, B, C, or if we went in the opposite direction, it would be C, B, A. Okay, because they all have vertex B can be any 3 of those angles. So that's why you can't just say angle B. You need to verify, well, which angle are you talking about? Are you talking about this little section right here? Are you talking about this little section right here? Or are you talking about the whole thing? So that's when you have to use the 3 letters. Okay. All right. So classification of angles. So this is a little review of middle school. It says the 4 types of angles are described in the table below. Okay. So when we have acute angles is when it's less than 90 but more than 0. Okay. And that's because we do not work with negative angles right now. So this is angle A. Okay, this is an example of acute angle less than 90. And then we have what we call a right angle. So a right angle is exactly 90 degrees, which goes straight across and straight up and down. So that's a 90-degree angle. And we have obtuse angles, which are greater than 90 degrees. So if we notice here, angle A is between 90 and 180 degrees. So we can see that it's well over 90. It's bigger than this angle over here. You can see. But it is less than 180. And the reason that it has to be less than 180 is because when it is exactly 180, this is called a straight angle. Okay, so if you see a straight line would be 180 degrees. All right, so here it says use a diagram to identify the angles as acute, right, obtuse, or straight. Okay, so let's go ahead and look at the first angle that they want us to look at. It is the measure of angle BEC. So I'm going to start off with B to E to C. BEC. So it's talking about this angle here. They just want us to tell us whether it is right, obtuse, or straight. So this is acute. Sorry, I missed that one. Acute. It's less than 90. Okay, the next part is from D to E to C. So from D to E to C, this is exactly 90 degrees. As you can see right here, it does say 90 degrees. So this is a right angle. Okay, BEB. So from D to E out to B. Okay, so this one is more than 90 degrees. So this is obtuse. Then we have BEA. So B to E to A. That is going to be a right angle. An acute angle. It's less than 90 degrees. Okay, the next one is going to be AED. So from A to E to D is going straight across. So this is called a straight angle. Straight. And last we have CEA. So from C to E to A is going to be 90 degrees exactly. So this is a right angle. Okay, so now they're asking us to use a diagram to give the measures of each of the following angles. So now we're going to give an actual angle measure. We're not going to say what it is. We're going to give an angle measure. So I'm going to go ahead and erase this so we don't get all confused. It did get a little messy. So we have AEB. So from A to E to B, let's go ahead and take a look. So because it starts right here down at 0 and then it goes all the way up, we're going to go ahead and look at these numbers here. Okay, those numbers, one says 120 and the other one says 60. Okay, the way that you pick the number is, well, this is obviously an acute angle, so you're going to pick the one that's less than 90, which is 60 degrees. Okay, the 120 would be if we started here at DE and then went over to this angle right there. That is 120 degrees. But we're not, we're going in this direction, so that's why we use the 60, okay? Let me go ahead and erase all those markings so it doesn't look super messy for the next one. Oh, I didn't realize I erased the 60. All right, the next one says CEB. So from C to E to B. So this one doesn't start at 0. So unfortunately, we can't just look at the numbers this time. Okay, but what we can do is we can count the spaces. So I'm going to zoom in so we can see it. This is 90. And then if we notice from here to here, it doesn't tell us what it is, but it's 5 little tally marks. And then this would be 5, 10, because from 90 to 100 is 10. So 5, 10, 15, 20, 25, 30. So that's going to be a total of 30 degrees. Okay, if you didn't want to do that, you can subtract the numbers if you want. You have 90 and you have 120. Or you could do 90 minus 60. Both of them will give you 30, okay? Oh, let me erase those. All right. The next one that we're going to find is DEB. So from D to E to B. Now this time, this is the obtuse angle, okay? It does start at 0 and then it comes all the way around this way. So we're going to use a bigger number all the way to here, which is 120, because this is the obtuse angle. And then last, we have the measure of angle D, E to C. So from D to E to C, we can see it is exactly 90 degrees. So 90. All right, here it says angles are congruent if their measures are equal. Arc marks are used to show that the two angles are congruent. So these little marks in here, these are called arc marks. So when you see them on angles, they put that to tell you that they're the exact same measure. Okay, so then the next thing that we're going to look at is what we call an angle bisector. So it is a ray that divides an angle into two congruent angles. Okay, so if you notice, this ray right here is an angle bisector. And we know that because this says 48 and this says 48. So that means they're exactly the same, which means VW is cutting it in half. So it says use a figure to name the two congruent angles. So the first one is going to be this one right here. Now remember, we can't just say angle V because angle V can be this angle on this side, the opposite angle, or the whole thing. So we're going to say angle XVW is congruent to this other side here, which is WVU. So angle WVU. Then it says identify the angle bisector. Well, what's cutting this angle in half? It's a ray that's cutting it in half, and it is ray VW. Okay, which I showed you right here, ray VW. Sorry, it's hard to make a straight line with this pen. All right, the next part says find the measure of each angle. Transfer the information to the diagram before you start working. Okay, so if they do not give you a diagram, make sure that you do draw one, but here they do. They tell us the measure of XWZ is 121. So XWZ is 121. That means this entire angle from here to here is 121 degrees. Then they tell us that the measure of XWY is 59. XWY is 59 degrees. Okay, so then they want us to find YWZ. So YWZ. So they want us to find this angle in here. We don't know what it is. That's what we're looking for. So just like we had a segment addition postulate, it's kind of like we have an angle addition. Okay, so if I take 59, I'm going to write it here, 59 plus whatever this angle is. I don't know what this angle is. I put a question mark here, but on our equation, I'm going to call it X, okay? And then it should equal the whole thing, okay? The whole thing they told us was 121. So in order for us to figure out what X is equal to, we do 121 minus 59, and that gives us 62. So that means angle YWZ is 62 degrees. I think when I printed this out or when I changed it to a PDF, it missed some symbols. As you guys can see here, it completely transferred. Oh man. Okay. Sorry, it kind of shifted everything around. So this right here, this equals 2x plus 1 should be up here. Okay. So I'm going to go ahead and fix that real quick. Equals 2x plus 1. And then I'm just going to erase it here so that we don't get too confused. Hopefully it didn't mess up a whole lot. I hope this should be the last problems. Yeah, okay. So that's better. Okay, so here they tell us that the measure of AXB is equal to 49. So we're going to go ahead and transfer that over. AXB is just this little section here. So this is 49. Okay, and then they tell us that the measure of BXC, so B to X to C, this angle in here is 3y plus 3. Okay, and then they tell us that AXC, which is the whole thing, A to X to C, this whole thing here, so both of the angles put together should give us 11y plus 4. Okay, so we're gonna have to set up an algebraic equation for this, okay? The two little parts of the angle, which are 49 plus the 3y plus 3 is going to equal the whole thing, which is 11y plus 4. 11y plus 4. And we're going to solve for y. So on the right side, the 3y, it doesn't have any other y's to combine with, so it's going to stay as 3y. Plus, we have 49 and 3 together, that gives us 52. This equals 11y plus 4. Okay, so we're going to start solving for y, so I'm going to move over the y to the left side. And this gives us negative 8y plus 52 equals 4. Our next step is to move over the 52 to the other side, and we do so by subtracting. So we're left with negative 8y, and then 4 minus 52 gives us negative 48, and our last step is to divide by negative 8. So now that we found out that y is equal to 6 when we divided, y equals 6, we can go ahead and plug them into the equation. See this? I don't know why the angle symbols did not come out. Okay, they should be in there. All right, so I'm going to go ahead and take this 6 and plug it in here. So 3 times 6 plus 3. So 3 times 6 is 18 plus 3 gives us 21. So that means the measure of BXC is 21. Then we plug it in here. 11 times 6 is 66 plus 4 gives us 70. That's it. Okay, so let's go ahead and try this one another time. This one is a little bit different because if you notice here, we have WOX is 2x plus 1. So WOX is this little angle here. This is 2x plus 1. Then they tell us XOY is 3x minus 9. So XOY is 3x minus 9. Then it tells you OX is an angle bisector. Okay, this is an important piece of information because this tells us that we solve it a little bit different than the last problem. That means that this cuts it into two equal parts. This angle here should be equal to this angle here. So it's different when we're setting it up because we don't add these together. We set them equal to each other. Okay, because they should be equal. 2x plus 1 equals 3x minus 9. So there's two things it tells us that they're equal. The first thing is that it says it's an angle bisector, OX. And the next thing is that they put the little arc marks in here to show us that they're equal. Okay, so that's how I know when I set it up, I set both of those equal to each other. And then we start solving for x. So I move over the 3x to both sides. By subtracting, it cancels. We get negative x plus 1 equals negative 9. Sorry, my pen's not working. Negative 9. There. Then we subtract the 1. We get negative x equals negative 10. And our last step to solve for x is to divide both sides by negative 1. This cancels. We get x equals negative 10 divided by negative 1 is a positive 10. So now that we know what x is, we can go ahead and plug it in for the measure of angle WOX is 2 times 10 plus 1. That gives us 21. And then for XOY, no, it says WOY. So WOY. So they want to know the whole thing. Well, we know one of the sides is 21, so that means both of them are 21. So the whole thing together would give us 21 plus 21 gives you 42. And that's it. Thank you guys for watching. Bye.